Hello, today I'm going to instruct how to write the correct rate law expression, reaction order, as well as K, which is the specific rate constant, by giving the following equations and experimental data. First, let's take a look at our first question. So in order to find the rate law expression, we need to find the specific exponents for A2 and B2. In this case, we focus on experiment data 4 and 5. We notice from A2, it multiplies by 2, and the rate is actually multiplied by 4. So the exponent should be 2, because 2 with the power of 2 equals to 4. And to find the exponents for B2, we focus on experiment 1 and 2. So from 1 and 2, B2 multiplied by 2, and the result also multiplied by 2. So in this case, the exponent is 1, because 2 with the exponent 1 is equal to 2. And when we add these two values together, when we add these two exponents together, it gives us the reaction order, which is 3. And to find the K, we plug the value of our first experiment into the equation. So we use our rate divided by the concentration of our A2 with the exponent 2 times concentration of B2 with the exponent 1. And we plug the value of 0.001 for A2, and B2 is also 0.001, and the rate is 0.01. So in this case, we get the number of 1.0 times with the 10 exponent 7. And just to reminder, our units for concentration is moles per liter. So in this case, the A with the exponent 2. So the units also have to be with the exponent 2 with the power of 2. And B2 is with the exponent 1. So our units is just moles per liter. And when we cancel out all the units, we get the final units for our K value. And the same idea applies to our second question. So we have to find the exponents for C and D in this case. To find the exponents of C, we focus on experiment 4 and 5. So from 4 and 5, the C multiplied by 2, and the rate multiplied by 1. So 2, we know 2 with the exponent 0 is equal to 1. So in this case, C's exponent is 0. And to find the exponent for D, we focus on experiment 1 and 2. So D times 2 from 1 and 2, and the reaction rate times 2, also times 2. So in this case, the exponent should be 1, since 2 with the power of 1 equals 2. And when we add these two exponents together, which is 0 plus 1, which is give us the 1 order. So this is the reaction order And to determine the K, we follow the same step. Its rate divided by the concentration of C with exponent 0 and concentration of D with exponent 1. And we also have to plug in the experiment 1 data for all three values. So we get the final answer of 2. And also we have to remember to calculate the units, which is also how to be the power of exponent. And we have to cancel out the units to give us the final units of K, which is 1 over S in this case. And let's move on to the third question. So similar idea. In this case, our first concentration is F, and the second one is G. And to find the exponent of F, we choose the first and 2 experiment. So F multiplied by 2, and the rate also multiplied by 2. So in this case, the exponent should be 1. And to find the exponents for G, we focus on experiment 4 and 5. So G multiplied by 2 from the exponent 4 and 5, and the rate also multiplied by 2. So G also have an exponent of 1. And when we add these two exponents together, it gives us the second order for the reaction rate. Sorry, so for the reaction order. And for the third, it's asked to find the K value. So follow the similar process. We will rate divided by the concentration of F with exponent 1, and concentration with of G with also with exponent 1. And we plug the value of first experiment in here. So it will give us the final answer of 5. And we also have to plug in all the units. So the units also have to be the power of exponent. And we cancel the units, and then we will get the final units for K. And let's move on to the next question. So in question 4, we get the similar idea. We have to find the exponents of C and D. So with exponents of C, we focus on experiment 4 and 5. So in this case, C multiplied by 2, and the rate actually multiplied by 4. So 2 with the exponent with the power of 2 equals to 4. So we get the exponent of 2 for the C. And then when we focus experiment 1 and 2, we notice D is multiplied by 2, and the result is multiplied by 4. So 2 with the exponent of 2 is equal to 4. So D also have an exponent of 2. And 2 plus 2 equals to 4. Let's give us the reaction order of 4. And follow the similar process. We will rate divided by the concentration of C with the power of 2 times concentration of D with also a power of 2. And we plug the value of first experiment and give us the final answer of 20,000. And we plug all the units. So units also have to be in a power of 2 in this case for the denominator. And when we cancel out the units from the numerator and denominator, we get our final units for k. So let's take a look at our fifth question. In this case, we need to find the exponents of f and g. To find the exponents of f, we can focus on experiment 1 and 2. So f multiplied by 2 and the result is multiplied by 8. So the 2 with the power of 3 equals to 8. So f in this case have a exponent of 3. And g, we can take a look at experiment 4 and 5. G multiplied by 2 and the rate multiplied by 4. So in this case, 2 with the power of 2 equals to 4. So we get the answer of 2 for the g's exponent. And 3 plus 2 equals to 5. So let's give us the reaction order of 5. And follow the same process. We get the k from rate divided by the concentration of f with the power of 3 times the concentration of g with the power of 2. And we plug the first experiment data in. And we'll get the final answer of 12 125,000. And where we plug all the units, remember our units also have to be powered. So in this case, it's 3 and 2 with the power. So we will cancel out the units from numerator and denominator to give us the final units of k. And that's all the question. Thanks for your watching.